We learned about points and lines, and that's good because we're going to need lines to make angles. So let's start with a couple of lines that are in the same plane. We're only going to be dealing with two-dimensional geometry in this video. These lines are conveniently called line AB and line CD. Now, the important thing to notice about these two lines is that they're pointing in exactly the same direction. So even if we extend them forever, they would never cross or even get closer together. When two lines are arranged like this, we call them parallel. Now, you've probably heard the term parallel before, like parallel parking or a parallel universe or parallel bars. Okay, so parallel lines are lines that will never cross, even if they go on forever. But what if I take one of our lines and give it a little nudge? Now the lines aren't parallel anymore. In fact, they cross at this point right here. Let's name it point P. When lines cross at a point like this, we say that they intersect, and we call the point an intersection. And when lines intersect, they form angles. You can think of the angles as the spaces or shapes that are formed between the intersecting lines. These intersecting lines form four angles: 1, 2, 3, 4. But instead of calling them angle 1, 2, 3, and 4, in geometry, we name them by the points used to make them. For example, this angle here can be called angle DPB, because if you trace along those points, like connect the dots, they outline that angle.
You could also call it BPD, as long as you make sure the middle point that makes the intersection is in the middle.
And this angle here, we can call that angle APD, because
or DPA.
Connecting those dots forms that angle. Now, when naming angles, there's a nice shorthand that we can use. Instead of writing the word angle over and over again, we can just use the angle symbol instead, which looks like this. But there's an even simpler way to name angles. To learn that way, let's erase all the points and letters on our lines, except for the intersection point and this one point here. Now let's imagine that the line segment between these 2 points can rotate around the point of intersection, just like a clock hand rotates around the center of a clock. Let's also imagine that as we rotate the line segment, the point out at the end leaves a trail, like if a pencil was attached to it. The trail, or path, that's left when we rotate the line segment all the way around forms a circle. But if we only go part way around, then it forms part of a circle that we call an arc. This arc can represent the angle that's formed when we rotate the segment from one position to another, like from this line to that line. And now, if we shrink down that arc so that it's close to the intersection point, and then put a letter by it, like the letter A, we have another way of showing an angle, angle A. And we can do this with any angle. So the angle up here, we can also draw an arc and call it angle B. So whenever you see a letter next to a little arc like this, it means that it's the name of the angle formed by that arc.
Usually we label it by all 3 points though, but still handy to know.
Alright then, so now we have a diagram that shows angle A and angle B. And you might notice that those angles aren't the same size. B seems to be bigger than A. But what if we rotate one of our lines until the angles do look like they're the same size? Now our angles look kind of like a plus sign. Lines arranged like this are called perpendicular. Perpendicular lines are lines that form square corners when they intersect. And these square corner angles have a special name in geometry because they're really important. We call them right angles. There's even a special symbol that we use to show when an angle is a right angle. Because they form square corners, we use a little square instead of the arc that we use for the other angles. So whenever you see this symbol, you know that the angle you're looking at is a right angle, and that the lines that form it are perpendicular.